Hi, this is the PRML project Spotlight video presentation, and our project is of object recognition. Myself, Arnav Srivastav, and let's start. These are the contents of this video presentation, and we'll continue on with the project overview. Our project basically focuses about image classification tasks on the famous Cipher 10 dataset. And what we want to achieve is doing analysis of the ML models which we have studied in this course. The various models which were used for initial testing were k-nearest neighbors, decision tree, random forest, naive Bayes, and SVM model. So the initial testing results are as follows. We can see that the models show quite a poor performance in classifying images, which was quite obvious, and as they are not suited for this task. So let's move forward. Why did these models fail is because the primary reason was that these models were unable to capture the image features, this is because the pixelated data is related to each other to make the features of an image, and these models failed to do so. Also, decision trees are very prone to overfitting, and due to this huge dimensions in this data set, KNN and tree based datas fail to perform in this task. So what we can do to improve this performance? The first approach which we tried was reducing the dimensions. Two common techniques for doing so are LDA and PCA. And after applying both of them, we see these results. The only improvement which we see is in case of naive Bayes, that after LDA we see an increase of a 7% accuracy. Except for anything else, the results seemed quite the same. So what could have been the problem is that after reducing the dimensions, we lost quite a bit of information, due to which the machine learning models failed to learn anything about the image features. The next approach was using feature extraction from the ResNet50 dataset, of which we were provided the template code by a professor in this project course. What ResNet50 actually is, it's a very deep convolutional neural network which incorporates residual learning, and it is quite suited for this image tasks. We use a pre-trained ResNet50 and use those features to now train our machine learning models, and we see a very big increase in accuracy in case of all the models, and this is because the new features that we use for training were quite good and had all the details about the features, and thus the ML models were doing quite well. The next approach was also provided in a template code by using histogram of gradients. These are the new accuracies, and we can see they are better than the initial results, but not as good as using feature extraction from ResNet. What Hawk actually does is uses histograms about this pixels edges and gets an image like this, which is good in getting an outline of the image and getting somewhat details about the image, but it is not as good as ResNet50 in capturing the intricate details about the image. And the final step was doing some fine tuning in some of our models. Like in the KNN model, we did some cross validations with various k values and find out the best k value. About all other models, we used grid search and randomized search to get the best hyperparameters for each of these cases. These are the final accuracies, and the best accuracy which we got was on fine-tuning SVM model on the pre-trained ResNet features, and the accuracy is 0.89. Doing some failure case analysis for all of these graphs, we use misclassifications and other approaches to realize what could have been going wrong in the initial cases. What we can see here is that the models classify automobiles as truck in majority of the cases, which is quite reasonable, and similarly which we have done for all classes. These are some future prospects about what could have been done in this project, and which can be done in the future as well. What we learned is like applying featuring engineering is a brilliant idea and should be used more in all of these projects. What can be done is using ensemble techniques, combining different machine learning techniques and ideas to do more. So this is a ML model in action. Uh, the original labels and the predicted labels. And thank you. That's it.